Hello everybody and welcome today in my new video, and we'll be talking about steam power and about atmospheric water generation. Why is this so important? Because energy independence means the independence of humanity, and becoming energy independent is one of the greatest forms of revolt you can do right now. We need to be energy independent and we need to be food independent before we can be independent, because these global Bolshevik communists, what they do is centralize the food supply, make sure they control all the food sources, make sure they control all the energy sources, and that's how they enslave humanity. That's how they done it. In Russia, in the communist revolution, they centralized all the food supplies, and that's how they enslaved the entire Russian people. This is what they're doing to the entire globe right now. They're destroying local and green food production. They're destroying the farmers, and they want to create a centralized food production. They've done this with energy. With energy, this is already has been done, and we have been made dependent of the government and of their institutions, of multinationals, to get our energy. Well, there is energy everywhere. There's energy in the sky, there's energy in the wind, there's energy in the sun, there's energy in abundance, and there's energy everywhere. We are made of 95% of water. The earth, the globe, is made of 70% or more of water. And we can use this water in a very efficient way. And no, I'm not talking about a crude steam boiler, but this would already work very well. But there are many very good solutions in the modern era how to apply steam energy in a very efficient way, and I'm going to show you that right now in my video. So please stay tuned. So steam engines are definitely viable for the future. For this video, I've done a lot of research, I've compiled a lot of videos and a lot of pictures for you, and I've written an extensive essay on the usage of steam engines, etc. So I will dive right into it. I hope you enjoy the photos and videos, including photos of the old world, and you'll get a detailed description of the usage, the working of steam engines, and how we're going to apply that for the future. Also, we're going to discuss the Tesla turbine and atmospheric water generation. The video will also include a step-to-step guide how to build a steam engine and how to build a Tesla turbine, and you will be able to find everything back on my locals, the entire essay I've written. You will be able to find it back right there, so please support the channel and join my locals. So first of all, the greatest thing about steam engines is that the water used in the steam engine typically is recycled and returned to the ecosystem. Here is how it typically works. Water usage in a steam engine. Water is heated to produce steam, which is then used to drive turbines or pistons for mechanical work, such as electricity generation or locomotion in trains or steam cars. As the steam expands and does work, it loses some of its heat and energy and condenses back into liquid water. Condensate recovery. The liquid water produced from condensed steam, known as condensate, is collected and often recycled within the steam system. Condensate recovery systems capture and reuse this water, feeding it back into the boiler to be converted into steam again. This recycling process minimizes water consumption and ensures efficient use of resources. Water quality and treatment. Before being reused, condensate may undergo treatment to remove impurities and contaminants picked up during the steam cycle. This treatment process typically involves filtration, chemical treatment, and sometimes additional purification steps to ensure the water meets the quality. Discharge into the ecosystem. While some water may be lost due to evaporation or blowdown from the steam system, the majority of the condensate is returned to the ecosystem. In industrial settings, condensate may be discharged into waterways treatment systems or released back into natural water bodies, such as rivers or lakes, after treatment to meet regulatory requirements. Environmental condensations is essential to manage the discharge of condensate responsibly to minimize environmental impact. proper treatment and monitoring ensure the discharged water meets water quality standards and does not harm aquatic ecosystems or human health. Overall, the water used in steam engines undergoes a closed loop cycle where it is recycled and returned to the ecosystem with minimal waste. This approach maximizes water efficiency and minimizes the environmental footprint of steam engines operations. In the vast landscape of technological evolution, few inventions have left such an indecisive mark on human history as the steam engine, originating in the 18th century. But if you ask me, way before, these mechanical marvels ushered in the Industrial Revolution, transforming the world and catalyzing unprecedented process. But while many may perceive steam engines as relics of the past, their potential in the modern era remains remarkably relevant, particularly in the pursuit of sustainable green energy solutions. So, at their core, steam engines harness the power of steam to generate mechanical work by heating water to produce steam, which then drives pistons or turbines, and these engines convert thermal energy into motion. This fundamental principle may seem archaic, yet its application in today's world are both diverse and promising. Consider, for instance, the pressing global imperative to transition away from fossil fuels and mitigate the impact of climate change. In this context, steam engines offer a compelling alternative. Unlike traditional combustion engines that rely on finite and polluting fuel sources, steam engines can be powered by renewable energy. Inputs such as biomass, solar heat, and geothermal resources. By utilizing sustainable fuel sources, steam engines present a pathway towards decarbonization and reduced reliance on non renewable resources. Furthermore, the versatility of steam engines extends beyond electricity generation. In industries ranging from manufacturing to transportation, these engines can drive a wide array of machinery and vehicles. Picture a modern steam powered locomotive silently gliding along a railway station, emitting nothing but water vapor into the atmosphere. Envision industrial processes powered by clean and renewable steam, driving productivity without compromising environmental integrity. Moreover, the integration of steam engines with emerging technologies like advanced materials and digital control systems opens up a new frontier of efficiency and performance. Through innovations in materials science, engineers can design steam engines that operate at higher temperatures, at pressures, maximizing energy conversion efficiency. Meanwhile, sophisticated control algorithms optimize the operation of steam systems, ensuring seamless integration with renewable energy sources and grid networks. But perhaps the most compelling aspect of steam engines lies in their inherent scalability. From small scale decentralized application to large scale power plants, steam technology can be tailored to meet energy needs of diverse communities and industries. In regions lacking access to conventional power infrastructure, decentralized steam systems offer a reliable and sustainable energy solution, empowering local communities and driving economic development. In essence, the resurgence of steam engines in the modern era represent a convergence of tradition and innovation, heritage and progress. By embracing these time-tested technologies and reimagining them in the 21st century, we can forge more sustainable futures for generations to come. So let us not consign steam engines to the annals of history, but instead embrace them as catalyst for a greener, more equitable world. The age of steam may have dawned centuries ago, but its brightest day lie ahead, fueled by the boundless potentials of green energy and human ingenuity. Improving the efficiency of steam engines while reducing water consumption is a key challenge. Modernizing this technology for clean energy. Here are some of the examples how this can be achieved. For example, with an advanced boiler system design, utilizing advanced materials and engineering techniques can enhance boiler efficiency, allowing steam engines to extract more energy from the same amount of water. High efficiency boilers with improved heat transfer surfaces can minimize heat losses and optimize steam generation. Also, condensing systems, incorporating condensing systems into the steam engine enables the recovery of water vapor from exhaust steam by condensing steam back into the liquid water. This process recycles water within the system, reducing overall water consumption and increasing its efficiency. Another way is a closed loop system. Implementing closed loop steam systems minimize water losses by recirculating condensed water back into the boiler. By continuously circulating water within a closed loop system, steam engines can operate with minimal water replenishment, making them more efficient and sustainable. Water treatment technologies. Investing in water treatment technologies ensures the quality and longevity of steam engine components. Purification processes such as reverse osmosis or ion exchange can remove impurities from feed water, preventing scaling and corrosion that can reduce efficiency and increase water consumption. The waste heat recovery. Integrating waste heat recovery systems allows steam engines to utilize excess heat from various processes, reducing the need for additional fuel or water input. By capturing and repurposing waste heat, steam engines can operate more efficiently while conserving water resources. Then you have optimized steam turbines. Upgrading steam turbines designs with modern materials and aerodynamic optimizations can enhance the energy conversion efficiency. High efficiency turbines extract more energy from steam, requiring less water input for the same power output. Also, we have variable speed control. Implementing variable speed control mechanisms allows steam engines to adjust their operating according to demand, optimizing energy usage and water consumption. By modulating steam flow rates and engine speed, variable speed control ensures that steam engines operate at peak efficiency under varying load conditions. Cogeneration systems as well. Deploying cogeneration systems that produce both electricity and heat can improve overall efficiency and water usage. By utilizing waste heat from electricity generating for heating purposes, cogeneration systems maximize the utilization of energy resources while minimizing water consumption. By incorporating these strategies, steam engines can be transformed into highly efficient and sustainable energy solutions, capable of meeting the demand of the modern era while minimizing their environmental footprint. So of course you want to run the engine on minimal heat. You don't want to be stoking coals like in old steam trains. So running a steam engine on minimal heat requires careful consideration of several factors to ensure efficient operation while conserving energy. Here's an explanation on how this can be achieved. Efficient boiler design. The heart of any steam engine is its boiler where water is heated to produce the steam. Utilizing an efficient boiler design is crucial for running the engine on minimal heat. Insulating the boiler properly helps retain heat, reduces heat loss to the surroundings, and allows the engine to operate efficiently with less fuel input. Of course, we have optimized fuel combustion. When used traditional fuel sources such as coal, wood, or biomass, it's essential to optimize the combustion process to extract the maximum amount of heat energy. Proper air fuel ratio control and combustion chamber design ensure efficient fuel utilization, allowing the steam engine to generate adequate steam with minimal heat input. And we go to the heat recovery systems. Implementing heat recovery systems allows the steam engine to utilize waste heat from various processes. Heat exchangers can recover heat from engine exhaust gases or cooling water, preheating the boiler feed water and reducing the amount of heat required to generate the steam system. This approach maximizes energy efficiency and minimizes the need for additional heat input. Also, we have the closed loop steam systems. Closed loop steam systems recycle water within the system, reducing the amount of fresh water required to generate steam. By condensing exhaust steam back into liquid water and returning it to the boiler, closed loop systems minimize water consumption while maintaining steam engine efficiency. Additionally, condensate recovery systems capture and reuse condensate steam, further reducing water usage. Low pressure steam engines. Utilizing low pressure steam engines can allow for operation with lower heat input. Compared to high pressure systems, low pressure steam engines are well suited for all applications where high power output is not required, such as a small scale industrial process or agricultural machinery. By operating at lower pressures, these engines can achieve reasonable efficiency with minimal heat input. Variable load management. Managing the steam engine's load according to the demands helps optimize energy usage and heat input. By adjusting steam flow rates and engine speeds based on workload requirements, the engine can operate more efficiently with less heat. Variable load management systems monitor demand in real time and modulate engine operating accordingly, ensuring optimal performance while conserving energy. Thermal energy storage. And then we go back to, for example, my idea of a sand battery. Incorporating thermal energy storage systems allows excess heat generated during periods of low demand to be stored for later use. Thermal storage mediums such as molten salts, or sands or phase change materials can store heat efficiently and release it when needed to supplement heat input to the boiler. By storing excess heat, steam engines can operate continuously on a minimal heat input even during fluctuations in demand. By implementing these strategies, it's possible to run a steam engine on minimal heat while maintaining efficiency and sustainability. Whether for industrial applications, agricultural machinery, or decentralized power generation, optimizing steam engine operation for minimal heat input offers a viable pathway towards energy conservation and environmental stewardship. So, of course, there were also steam planes, and one notable example of a steam powered aircraft is the Basler steam plane, also known as the Basler steam airplane, designed and built by William Basler, an engineer with a background in steam locomotive technology. This experimental aircraft took flight in the 1930s. The Basler steam plane was powered by a steam engine that drove a propeller. The engine utilized steam generated by burning heavy aviation gasoline mixed with a specialized oil. The steam engine powered a compressor that pressured air, which was then mixed with the fuel and burned in a combustion chamber to generate high pressure steam. This steam was then directed to drive the engine's turbines, which in turn rotated the propeller to provide thrust. On May 12, 1933, the Basler steamplane successfully completed its maiden flight at Oakland Airport in California, USA. It flew for approximately 45 minutes, reaching an altitude of around 2,000 feet and achieving a top speed of about 85 miles an hour. That is 610 meters and 137 kilometers an hour. While the Basler steam plane demonstrated the feasibility of steam powered flight, it faced several challenges, including limited range, performance, and the complexity of the steam propulsion system. Despite its successful flight, the project ultimately did not progress beyond experimental stage, and the aircraft was not widely adopted. Nevertheless, the Basler steam plane remains an intriguing example of early efforts to explore alternative propulsion technologies in aviation. Its legacy continues to inspire ongoing research and experimentation in the quest for more efficient and sustainable aircraft propulsion systems. And combining this all with the atmospheric water generation, which I already made videos about, but what I will go more into depth right now. Combining the atmospheric water generation (AWG) technology with steam engines presents an innovative approach to sustainable energy and water production. Here's how such a system could work and its potential benefits. Atmospheric water generation utilizes condensation principles to extract water vapor from the air, even in arid or humid climates. This process typically involves cooling the air to its dew point, causing water vapor to condense into liquid water, which is then collected and purified for use. Integration with steam engines. In a system combining AWG with the steam engines, the generated water could be used as feed water for steam production. The collected water would be purified to remove impurities and then fed into the boiler of a steam engine system. As the water is heated to produce steam, it undergoes phase change, expanding and generating mechanical energy to drive turbines or pistons. Renewable energy input to heat the water and generate steam. Renewable energy sources such as solar thermal energy or geothermal heat could be utilized. Solar concentrators or geothermal heat exchangers could provide the necessary thermal energy to power the steam engine systems. This ensures that the overall process is sustainable and environmentally friendly. Synergetic benefits. Integrating the AWG systems with steam engines offers synergetic benefits. Firstly, it provides a continuous source of water independent of traditional water sources such as rivers or groundwater, making it particularly valuable in regions facing water scarcity. Secondly, it enables the generation of clean renewable energy through steam power, contributing to efforts to reduce reliance on fossil fuels and mitigate climate change. Decentralized applications. This combined system could be deployed in decentralized applications such as off grid communities, rural areas, or disaster relief efforts where access to both water and energy is limited. By providing both essential resources in a self sustaining manner, it enhances resilience and improves the quality of life in underserved regions. Efficiency and sustainability. By utilizing renewable energy inputs and recycling the water through the steam cycle, the integrated AWG and steam engine systems promotes energy and water efficiency. It minimizes reliance and it minimizes the reliance on external resources and reduces environmental impact, making it a sustainable solution for both water and energy needs. Overall, combining atmospheric water generation with steam engines presents a compelling synergy between water production and renewable energy generation. This integrated approach offers potential solutions to address water scarcity, energy access, and environmental sustainability challenges, particularly in areas where it's needed the most. Nikola Tesla, renowned for his groundbreaking contributions to electrical engineering and technology, also developed a revolutionary steam turbine in the early 20th century. Tesla's steam turbine, known as the Tesla turbine or the boundary layer turbine, departed from conventional turbine designs of the time and offered several innovative features. 1. Bladeless design. One of the most distinctive features of the Tesla turbine is its bladeless design. Instead of using traditional blades to extract energy from the steam, the Tesla turbine relies on a series of closely spaced, smooth discs arranged on a shaft. As steam enters the turbine housing, it encounters the discs, creating a boundary layer effect that transfers momentum to the discs and causes them to rotate. Number 2, efficiency and simplicity. Tesla believed that this turbine design offered significant advantages over traditional turbine designs in terms of efficiency, reliability, and simplicity. The absence of blades reduced friction and wear and tear, resulting in smoother operations and potentially longer service life. Additionally, the design was less prone to vibration and stress, which contributed to its reliability. Number 3, scalability and versatility. Tesla envisioned his turbine as a versatile and scalable technology that could be applied in various industrial and power generation applications. He proposed using the turbine for electricity generation, propulsion systems for vehicles and aircraft, and even pumping and compressing fluids in industrial processes. Experimental applications. Tesla conducted numerous experiments and demonstrations to showcase the capabilities of his turbine design. He built prototypes and conducted tests to evaluate its performance and efficiency, garnering interest from investors and engineers. However, despite its promising features, the Tesla turbine faced challenges in commercialization and widespread adoption. You think twice why that is. That is exactly why that is, to sell us all the fossil fuels and to enslave us. While Tesla's steam turbine did not achieve the same level of commercial success as his electrical inventions, its innovative design and potential applications continue to inspire research and experimentation in turbine technology. Today, the principles underlying the Tesla turbine are studied and applied in various fields, contributing to advancements in turbine design and efficiency. Also, I will include in the video a link and a description of the page homeconstructor.net, where you will find a detailed description, step-by-step guide how to build your very own Tesla turbine. And my idea is also to build steam propelled vehicles, generating systems, atmospheric water generation, and all kinds of prototypes. I need your help because money doesn't grow on trees and I need some money to start building my prototypes. So join the channel, help me out. Also, every bright mind out there, I'm happy for all the help there is.
So we need to put an end to the global cabal and their grasp for global domination. We the people, we have the power and we can do it. Free humanity, let's save lives, let's save our neighbors, let's be good human beings. Let's fight for our freedom. Free humanity, make Earth great again, free Palestine, you know what it is. Masalam.